For more videos like this for discrete one, you can take a look at Sarai Studies, link is in the description box below.
First thing I do is label the gates. So in this first circuit, the gate that I see is the AND gate. So we can read this as A and B. So the formula for this circuit is A and B. But remember, formulas don't use words. They use operators like addition, subtraction, multiplication, division. In this class, we have to recall that AND is represented with multiplication and OR is represented with addition. So we replace this AND with a multiplication sign. And so we have that our formula is A times B, or simply just AB. Now, if you ever forget which one is multiplication and addition, you can always look at the word AND. It has an N, and if you just draw a line and think of it as an M, then M for multiplication. Here we have an OR gate because of this curved line. A straight line would be the AND gate. Now, this OR gate has two inputs. It has A or B. And so the output, we can represent it using a formula, is A or B. But again, with formulas, we want to use operators, not words. And in this class, we represent OR with addition. So we can replace the OR with a plus sign. Now, I say in this class because in discrete, we represented AND with the AND symbol. So A for AND, and then the opposite symbol would be OR. But when we're dealing with circuits, not just in this class, we represent AND with multiplication and OR with addition. This gate, the triangle with the circle, is what we call the NOT gate. It's just a fancy way of saying opposite. So if A goes through the NOT gate, what's going to come out is the opposite of A, or what we like to call not A. So we can say that our formula is equal to not A, but again, we don't like words in our formula, so how do we represent not? Well, we do it by just adding a tick mark, and we call this A prime, or we add a bar, and we call that A bar. So both of these mean the opposite of A, or not A. For this circuit, this is the exclusive OR gate. So it's just like the OR, it just has a curved line in front of it. So what is the difference between these two gates? Keep in mind that 0 means false and 1 means true. The only difference is that exclusive OR also outputs false if both of them are true. And the way that I remember it is if A is true, it does not want B to be true as well, because A wants to be exclusive, it wants to be special, it wants to be the only one that's true. So if A is true and B is true, the gate is going to be sad and it's going to output false. So the only way it ever outputs true is if at least one or the other are true and not both. So A could be true, but B has to be false, that's going to output true. A could be false and B could be true, that's going to output true. So there's only two cases where it's true. So the formula, the output, is going to be the cases where it's true. So again, that's when A is true and B is false. So we can just write A, and then how do we represent false? Remember that everything starts with being true. So if we have false B, that's not B, that's the opposite of B. And how do we represent not? With a prime or a bar. I like to use prime, so I'm going to do B prime. And then the other case where it's true, so we could say this is one case or another case. How do we represent or in a formula? With addition, so we could say plus the other case where it's true, which is just the opposite. B is true and then A has to be false. So B is true, we could just write B, and then the opposite of A would be A prime. And that is the definition of the exclusive OR.